Hello everybody, Patrick Lambolet speaking. I am very happy to be here with you during this connected event to exchange with you on the OPC UA. And I will briefly introduce myself. I am working for Schneider Electric, but I am here because I am the chair of the OPC France organization. And I will have the support of two colleagues and other members of this OPC France association, Michel Condemine and Thierry Dano. And these two experts will share with you a more technological view of OPC UA with Michel, and Thierry at the end of this presentation will share with you a concrete example and implementation of OPC UA in his work, in his plans. I will introduce the OPC UA organization. Normally, it's okay. Sorry. The OPC Foundation is a worldwide organization, and the goal of this organization and its vision is really to have a secure and reliable approach. Sometimes, and it's also a goal of this presentation, we heard that OPC and OPC UA is a protocol. We will see in this presentation that OPC UA it's not only a protocol, but it's a protocol plus a lot of other things, and the goal is really to share that with you today. You can see that the OPC Foundation today in June have 773 members shared all over the world. It's not only in Europe, but you have the split in Europe, in America, and also in Asia. You have also the list of the board of directors. The goals of this foundation, it's really to share. It's open to all kind of members. As Schneider Electric, I represent and I as part of this association as a provider of equipment, but we have also users of equipment and so on. It's very open, and a lot of kind of users are represented inside this organization and working together. The deliverables of the association are specification, are tools, are a lot of documentation for education, toolkit, and so on. And you will have some overview and example of what is delivered by the association today. Here it's just to share with you the big list and the logo of the members, but I remember that today more than 700 members are active and participate in the OPC Foundation. Additionally to the different members, the OPC Foundation is very linked to different associations related to the interoperability, related to the key action started in association or consortia. And you will see regarding different topics, typically IT with the link with E-class, the Dean for engineering. And here you have the list of the active participation and exchange and working session between OPC UA and these different associations. That's why, as I said previously, it's not only a protocol. You can see that we have, of course, some link with the major protocols, but it's not only that. You have also with energy. You have also with the different process automation to cover more just than the protocol. Just another view, the relationship also with the OPC UA Foundation in the world, and the strong link, the strong exchanges with the key local initiative, typically in US with the IIC, in Europe of course, with the platform industry 4.0, but also in China, in Japan, and in Korea, and more we have this interaction with the local initiative. And it's key for the association, the OPC UA Foundation, the OPC Foundation, to really ensure the link with the different areas in the world. Here, and after I will give the floor to Michel, just to finish this introduction, just to list the 3 pillars of the OPC UA, and the fact, and it's important for interop and standardization, because the OPC UA it's linked to this standard, the 62541, sorry, and the 3 pillars of OPC UA definitively are the interoperability, the data model, and the security, and it's these 3 aspects that makes the core of OPC UA, and you will have more details with Michel Condamine in the technical part. Thank you, Michel.
Okay.
Give you the floor.
Okay, thank you. Hello, everybody. Maybe I will try to share my screen. Okay. I'll share this one, switch to presentation mode. Okay, so I suppose you can see my screen. So I'm Michel Condamine. I'm working
Not yet,
on...
Michel.
It's okay? Okay.
No,
so,
no.
Oh, you cannot see my screen?
No.
Okay, share.
Yes, it's okay, Michel.
Okay. Okay, so you now can see my screen. I will talk about some technical aspect of OPC UA. So I cannot cover everything, but mainly the most important topics. But first of all, let me try to introduce myself. So I have several hats in my professional life. I'm the technical representative for the OPC Foundation, and I work on OPC UA for more than 20 years now. I'm also the CEO of the company called 4C Industry, where we make only OPC and OPC UA stuff. And I'm the leader of an open source initiative called Open OPC UA, started in 2009, where we try to implement in C++ for embedded systems, an OPC UA server and client. So let's try to dive a little bit in the technical aspect of OPC UA. So our agenda today is split in 5 bullets. So first we will try to take a look at OPC UA for regular LAN, so based on TCP and UDP. After that, we take a look at OPC UA for the cloud, so based on MQTT, AMQP, WebSocket, JSON, and XML. So I suppose you have a lot of questions on that part. Then something more close of embedded system is the deterministic aspect of OPC UA and the commitment of the OPC Foundation in the TSN technology. So it's drive us to the FLC initiative that is in charge of this aspect, and I will conclude with some words of a very important and very original aspect of OPC UA. It's OPC UA modélisation capabilities. But 4 very important information before we start. OPC UA first is not only a communication protocol. If you see OPC UA as a communication protocol, you miss, let's say, 60% of the technology. So first of all, let's say it's not a communication protocol, it's a technology. So it's made, there are protocols in OPC UA, but we have a bunch of protocol according to the solution we want to deploy. And we have several encoding, and we have for the modeling aspect, we have a meta model. Just now to present you an overview of what we are doing with OPC UA and where OPC UA can be applied. So we have 8 bullets. for that. So the first one is the IT-OT communication. It's where OPC is very well known. It's OPC in the PLC, in the controller, and SCADA system, in the MES system. So it's the root of OPC UA. It's where OPC was created at the beginning, and where OPC UA is developed today. So the idea is to transport, as the title of this slide, to transport information from the sensor to the cloud. So it starts from the sensor. So it's the IT-OT communication. Then we go to the cloud. We have technology to push. I already mentioned MQTT. So we have protocol envelope to transport data to the cloud. So everything in OPC UA is about secure. So we can have secure remote access to the plant. We have also local OT communication. So it's the bullet 4 for communication between controller to controller, but where that determinism is not that important. When it's very important, we have the bullet number 5 in controller to controller, and more than that in the bullet number 6, controller to field device communication. Today we are studying 5G integration. Nothing released at the moment, but a working group is active in the OPC Foundation, studying what can we do with the 5G and how can we integrate 5G in OPC UA. And for sure, bullet 8 OPC UA it's an always evolving technology, so it's future ready. Let's continue on to enter the history and the technical aspect of OPC UA. So OPC UA is more than 10 years. The original project started in 2005. The first specification was released in 2007. So another big release was released in 2009. And then in 2012, a big important update with new important features. I'll list the features and we'll share the slide with you. You can take a look at that in details after the presentation. So, and in 2015, we released the 103, maybe very well implemented today of the specification. After that, we released the 104 in 2018 with new features, pub sub features, TSN integration, new DP support, JSON. So a lot of big features. This is the current active version of the spec. And we plan to release the 105 beginning early in 2021. This is what we are working on at the moment in the OPC UA working group. So Patrick already mentioned that it's very important for the adoption of the technology, for the perennity of the technology, for the future of the technology. OPC UA is an international standard, is the 62541 standard, and you can find in numerous language the translation of every part of the specification. Just another slide sorry for that. So something to have a global overview. I like this slide because it gives you in one slide a nice presentation of an easy way to understand what OPC UA is. So OPC UA is two sides of one technology. So the first part is what I call the plumbing. So the plumbing is in charge of the communication between servers and clients. So you have a lot of plumbing and protocols and encoding to make this link efficient between the client and the server. So you can use TCP, UDP, WebSocket, MQP, MQTT, and you can encode in binary, in JSON, and in XML, everything secure, because security is everywhere in OPC UA. So the second side, the second aspect of the technology is the modeling capabilities of OPC UA. It's very unique in OPC UA. So the modeling aspect is created through a companion specification, and the companion specification is made of one numerical representation of the companion specification. Let's say just a file, it's an XML file conformed to a schema, and the documentation of this numerical representation. So it's created by experts and it's used by the end user that deploy this companion specification on the field on a real plant. So this one, just to show you that OPC UA is a multi-part specification. So you have several chapters, let's say several chapters that covers mainly. We can split those chapters in 3 pieces. One in charge of the protocol mapping at the very bottom of the slide. So you have some encoding, the binary encoding, the TCP transport, the WebSocket transport, the JSON encoding. So you have all the protocol related layers and information. You have in the second piece is the communication paradigm. It's so you have a choice between client server and pub/sub, publisher subscriber mechanism to communicate, all secure. You see, I draw a vertical red security, a rectangle to show that security is everywhere. And the third part is the modeling features and the modeling capabilities of OPC UA that concern the part 3, 6, 5, etc. You see, I mentioned all the parts, so you can refer to those parts and read it download it from the OPC Foundation. And you have what we already mentioned and what Patrick presents, what we call the companion specification, created in the context of collaboration with existing organization. But it's always possible, and it remains 100% compliant and interoperable, to create your own end user data model where you represent the way you see a knowledge and how to organize the information for your own needs. Just a little bit, let's say one use case. One use case is to use OPC UA for a regular TCP communications, for a communication between controllers. So controller can be PLC, CNC, robots, every embedded system that generate information and wants to push those information through TCP. So in that case, it's not deterministic. Every information are time-stamped at the source, so in the controller, and push to the network, maybe usually through a plant floor middleware, or the information are used by SCADA system, ERP, or MOM, or MES system, and PLM most of the time. So this is always in this client-server relationship. It's non-deterministic. It's everything time-stamped at the source, and it's for sure, as always, secure. The other use case is for non-deterministic but M2M communication, timestamp at the source, so timestamp by the controller, and always secure. It's for CNC to CNC or PLC to PLC, so it's UDP based. It's something we call a UADP. So it's a UDP with a binary encoding. Sorry for the French remain words. So it's a very new in 104. It was released 3 years ago, but it's already largely implemented in a bunch of server on the market and SDK and open source initiative. So this is let's say the last topic where we merge everything. So this is for the communication from the sensor to the web. So through MQTT. So let's say we collect information using UDP or TCP, and we push information. So here in this part we are in the plant, and we leave the plant. So the plant floor middleware is a publisher, and this publisher push the information using one of the 3 available technology, so MQTT, AMQP, or WebSocket, to a subscriber outside of the plant that wants to consume the information. So this subscriber can be any ERP or MES, or as always a SCADA system, or any kind of information. So here we have our 3 transport solution, MQTT, AMQP, and WebSocket, and 3 different encoding, XML, JSON, and binary. So it's a two-way communication. Again, it's non-deterministic because it goes through the web. It's time-stamped, and it's, as always, it's secure. So for the three precedent scenario, I said that it's not deterministic. So now let's try to consider a deterministic scenario. So in that case, we just change the hardware. We switch from regular Ethernet cards to a TSN-based card, and we have a UDP over TSN communication between controllers, and in that case, we can do a deterministic solution. So TSN, I give you the link here to the TSN project, where you can find all the information on the IEEE organization and about TSN. So you have to understand that in OPC UA we don't create everything. We reuse the technology. We create something sometimes when it's necessary, but most of the time, like for TSN, or like for, let's say, XML or JSON, we just use it, or MQTT. MQTT is an envelope for the OPC UA information and OPC UA encoded information. So just a slide about the footprint, because we are talking embedded. So OPC UA for sure can be implemented in server or clients, or OPC UA application in general can be implemented in various OSs and various hardwares. So you can implement very generally. You can create an OPC UA application with, as soon as you have a language, a programmation language that is able to handle a TCP or UDP socket, so using any TCP or UDP socket compliant language, so you can create an OPC UA application. You can run your application and create your application for any OSs or real-time kernel compliant with those language. So let's say in general GCC is available on embedded Linux, then you can create OPC UA application on embedded Linux. So the resource depend on the profile. In OPC UA we have the concept of profile that describe it's a functional profile, what your OPC UA application is able to do. But for the smallest profile we have, let's say that 50K of ROM and 100K of RAM is required to run a server. Now, if your server runs a very huge profile with archive, alarming mechanism, method call, and huge and complex secure mechanism, you need a little bit more resources. But most important is to understand that it's on the client server mechanism. The amount of RAM depends on the number of connected clients. Each client can create session, subscription, and so it's the amount of memory used by your servers depend on the resources required by your client. So just to conclude on that part, remember that OPC UA is strongly tied to secure technology. So if you want to create an application, you have to encrypt the encoded message exchange between the client and the server. So you have to create an API, an application for that, an API for that, or use an existing one. For instance, you can use OpenSSL. And it's what we do most of the time. So now just a couple of slides about the FLC initiative, because the FLC initiative is something quite new in OPC UA. It was started in 2018. So the purpose of FLC is to take OPC UA, to extend OPC UA for embedded system, for brownfield communication. And to put OPC UA more in the very low-level devices. So a bunch of companies joined, so all members of the OPC Foundation that joined the initiative. So this is where these circles show you where OPC FLC, where FLC initiative put OPC UA. So it remains OPC UA. It's just a working group studying all the capabilities and all the enhancement you have to we have to make to put OPC UA at this part of the process.
Just Michel, Patrick
Yes.
speaking.
Yes.
Just sorry to interrupt you, but we
Yes,
have
go on.
two questions on the chat.
We take the question now.
I don't know. As you want.
Okay.
No, as you want,
Maybe we can take all the question at the end, and I just finish and we take.
Sorry.
Okay, go on. I continue. So the FLC initiative, it's, let's say, 4 thematic. It's how to enhance OPC UA, what we have to use in to add to existing OPC UA for modeling, and what kind of model we have to create for FLC for embedded systems, for brownfield communication. So it's M2M. It's a very important topic. Every topic at the same time, for sure. We target the offline configuration and the functional security of an installation. So we can switch that between 3 aspects. So one is coming from our partners. So it's joint component specification. It's as I mentioned, it's TSN. So the two denomination of TSN. So this is TSN. The other part comes from the regular OPC UA existing specification and what the UA working group is doing at the moment. And then what is especially done by the FLC working group. So the FLC working group is working on those aspects, or IO facets, motion facet, safety facet, base device. So you can read it. It's mainly the topic I mentioned in the previous slide. I take some question. I keep that in mind. Just to conclude, it's another aspect. It's more general. It was what is very unique with OPC UA. So it's the modeling capabilities of OPC UA. So let's say the data is a profit center today. So we have, in order to manipulate and to make profit with that, we have to organize, valorize, and share those information. Share is very important, but we have to organize information in order to be able to share it correctly. We can say that the data are the today oil, but this is just oil. It's not crude, so we have to crude it or in order to valorize it. So OPC UA, you can see OPC UA as an infrastructure for data valorization. So valorize is the key word here, and you can use this infrastructure for that. So the modeling, what are the needs, or what is the needs? It's to use the plumbing, the OPC UA plumbing, very well implemented in various hardware and software, to transport your own data model. In many cases, model exists before OPC and before OPC UA, for sure. And for instance, Patrick mentioned in energy. In energy, there are very well-known norm called 611850, and 611850 don't wait OPC UA to exist, but OPC UA, but 611850 have its own model, and OPC UA is something very fair to transport the information and to exchange energy information between different business, between different organization and different software, not energy absolutely related. So now why to exchange? Just what I said, to express knowledge, semantic knowledge, some way, a specific way in a specific business to organize information, to represent functional rules specific to a business. So for that, we have a meta model. So the meta model, OPC UA meta model, is defined in the part 3 of the specification. You can see this meta model as a language to create models. So you learn the language, and you can create your own models. But we also have ways and creative ways to transfer, to go from UML to OPC UA language. But this slide raises a couple of questions. So first, how to create a model? How can we do that? How to create a completely new model for a specific business or a specific domain of application, or how to transform an existing model to an OPC UA model. And when you create your model, you have to instantiate the model because OPC UA is full object-oriented. So you have to create instance. So I can say that when you create your model, you create classes, and you have to instantiate those classes to put this data model alive. And then you want sometimes to reuse, to capitalize the object you create. Then how can we capitalize? Just a brief overview before my conclusion. So how what is an OPC UA model, and what it's all about address space. So in OPC UA, all is nodes. Every object are called nodes. So an address space is the sum between the start of the server and the stop of the server of types and instances. And for types, you have object types, variable types, reference type, and data type. It's a very important aspect. Data type, you can create your own data type. Let's say you take a type def struct from C, a regular type def struct, and you want this structure transport by an OPC UA variable. So you can easily do that with OPC UA without any alteration of your structure, as complex as your structure can be. And when you create your types, as I just said, you have to create instances. So instances are object, variable, method, reference, and views. And all this create what we call the address space. And the address space is what the server shows to the client application, to the outside world. To conclude, 5 very important bullets. So, sorry, 7 very important bullets you have to remember about OPC UA. So OPC UA is reliable. OPC UA is multi-platform. OPC UA is largely adopted, and it's secure. Very, very important aspect of OPC UA. OPC UA, it's all about interoperability. It's adaptable and scalable, and finally it's normalized. As I said, it's IEC 62541 international standard. So now, thank you, and let's go for the question. So the question.
Yes, we have.
Okay, a relationship between TSN and OPC UA. Practically, OPC TSN is used an hardware TSN with switches and TSN network card will use the UADP, so the UDP communication between UA application to exchange information. In fact, you have nothing specific to do in your existing OPC, not in your existing. If you implement yourself an OPC application or an OPC UA stack, so we are low level at this time. If you implement your own stack, you just have to implement UADP. If you implement UADP, then you deploy TSN hardware, and you are OPC UA over TSN. So this is different than what the FLC working group is doing. But for the first basis of the solution, you have nothing specific to do. It's just OPC UA is using TSN because TSN is a solution to make something deterministic over a network. So it's time-sensitive network. The other question is such as which protocol include TSN will interact with OPC UA. So it's a UADP. It's what the one we call UADP. So it's UDP with a binary encoding. When we talk about protocol with OPC UA, you have always to consider the transport. What is the transport and what is the encoding? We can make a bunch of combination between our transport, TCP, UDP, MQTT, and the encoding. And for encoding, we have binary, JSON, and XML. So, and you can mix all of that to make the what we call a stack profile, profile you want to use. But for TSN, we use UDP plus binary encoding. Okay. I don't see other questions. Maybe we can switch to Thierry.
Thank you, Michel. If you have another question, don't hesitate to use the chat for the question. And Thierry, the floor is yours.
I am ready. Do you see my screen?
Yes, it's okay.
Yes.
Okay, we can start. Just to introduce me, I am Thierry Dano. I work in Group Renault, and my job is to implement the technology of Industry 4.0, and in particular the data capture of industrial equipment and assets. Just for your for present my subject, we launched 3 years ago in Renault a working group to collect data from different assets, and we define what we would like to do in our industry, in our plants. We have many equipment and different plants, more than 30,000 equipment, and we would like to collect many information on this equipment to search the value, important value on this equipment. What we do exactly, we work on a specific approach where we would like to use OPC UA for the network and for the protocol, and a structured data model. And for us, since 2 years, the structured data model is most important than the OPC UA. What we do exactly, we implement a structured data model in a specific brick near the machine, and we push data in all level of ISIT to the cloud. It's the first step on our strategy, because in the second step, we would like to do machine-to-machine and local use of data. What we have exactly in on our side, we have a strong slogan and multiple user, because we have for the slogan we use collect once, use many. We think it's very important to have one solution to catch data, and we can, with this data collected, we can have many users. What we have deployed today in our plant, we have approximately 20,000 messages per second collected from all plant, from 80 plant for this moment, and we have prepared 22 plants to capture data from different equipment, and we have approximately 900,000 measured points at this moment, and we increase this data regularly because we connect new equipment in different plants. We collect a lot of data, and the curve of increase, the tendency of increase is very high, and we have many data collected, and we develop at this moment many use cases to use this data collected, and we have 3,000 equipment in OPC UA. In demonstration, I have just a small problem, because I have the ambition to show you in dynamic sometime, but there are incompatibility between the application of video conference and the VPN, and I can show just a static view of what we do. We have in our infrastructure, we have a dashboard with all the connected equipment for all the plant. We have it's static. I explained. Normally, you see in dynamic all the value per plant and per second, and the number of subscription we have, because we use a particularity of OPC UA standard. We have many value, many data exposed in the data ready or available in the data model, but function of the use case, we made the subscription or not, depending the usage of the data. We have at this moment 22 factory connected, and what we have in factory. I have just an example. It's Maubeuge, a plant in France, where we collect many data. We have more than 20 OPC UA server to collect approximately 1,000 of equipment. In this equipment, we have robot, we have PLC, we have a tightening controller, we have a welding controller, many types. And for a better understanding, in our plant, we have typically this a view of the data model we use, because in OPC UA there is some companion specification to describe a process, to describe an equipment, but there are not all needs for example, for Renault or for other. And we develop with an implementation of companion spec more our data model. We implement a different approach and in this screen you can see, for example, for this UA server, we implement a mechanical OP type. Is one of data model with one operation in machine, and we have several operation, several mechanical OP type. OP significates operation, and we have electrical precipitating, we have many data model we can expose. And if you see in this plant, the first we start last year, we have a different typology of data expose. It's one of our approach, and we use the functionality available on OPC UA. What we collect exactly? We have on the picture the completely connectivity of our plant, and we challenge each plant for the connectivity of the equipment with OPC UA. For example, you imagine when we have robot, it's very easy. When you have a standard data model, it's very easy to connect all the robots you have in different plants. And for example, in this screen, you have here for each plant in the blue, you have the robot we connected. At this moment, we have more than 1,000 robots connected. But when you have in this typically a plant, when you have many colors, the signification is we have many data model available, and we have here the list of data model we implement at this moment, and we have in reserve a lot of data model because we implement new line for example, electrical powertrain and other typology of new implementation in process. What we have exactly on our screen, we have a very huge volume of data, and we use OPC UA to collect the file. For example, we have in some machine, some equipment, we have the image of quality, for example, or image of result of some equipment, because that doesn't talk in OPC UA at this moment. We need for a temporary step to collect a file before the next step where we have a complete data model in equipment. And the number of value is very important. And you see here, since 2 years, there is a lot of data collected, and the number of OPC UA server connected, equipment connected, is increased regularly. And we see, for example, when we stop our plant during the shutdown, summer shutdown, we implement new connected equipment in our plant. And you see, when we pass the month of August, we have an important increase of connected equipment. And just a sample example, we have what we do with the with the data. Here you have the information about our robot connected, and the different color explain the typology of the robot. We have some welding robots, some robot from stamping, and for other. And we have some typology because we have a specific application, a specific software for each application, and we can trace all the version and all the typology of equipment we have in different factories. And because I have a problem with the compatibility of VPN, I stop my presentation at this moment.